Activity 2.9 begins with the distributive property. I want to illustrate for you how the distributive property works using rectangles. Now, suppose we have a rectangle split into two parts. This rectangle has a height of 3 units, an overall width of 15 units, broken into two pieces of 6 and 9. If we wanted to calculate the area of this rectangle, we could do it in two ways. We could take the length of the base and multiply by the height. Or we could find the area of the separate pieces. One of them would be 3 times 6, and the other would be 3 times 9, and the total area would be the sum of the two. Now, we get that width of 15 by adding the 6 and the 9. And what the distributive property tells us, and what we can see from the diagram, is that 3 times the quantity 6 plus 9 should be equal to 3 times 6 plus 3 times 9. And a quick check will tell us that's true. In both cases, we get 45. We get 45 straight out on the left. On the right, we get 18 plus 27, which is also equal to 45. So the distributive property tells me that when I'm multiplying, I can distribute that 3 over the sum to both pieces. Now the nice thing about the distributive property is it doesn't matter how many pieces it's broken into. I can distribute over all of them in the same way. So 4 times 2 plus 7 minus 3 would be equal to 4 times 2 plus 4 times 7 plus 4 times negative 3. This is exceptionally helpful when we have variables and we want to simplify an expression. For instance, 2 times x plus 5. In this case, I distribute the 2 to the x and to the 5. Now I don't know what x is, so I don't know the exact value of 2 times x, so I just write 2 times x. And I know that 2 times 5 is 10. Four times 3x minus 5, I would distribute the 4 to the 3x and to the minus 5. Get 12x minus 20. That's how the distributive property works. It works even if the number out front is a negative. And even if I have multiple variables. Negative 10x times a positive y is going to give me a negative result. I'm going to have negative 10x times y. Negative 10x times positive 11 is also going to give me a negative result, negative 110x. If I have a negative sign in front of a parenthesis, sometimes it's helpful to see it as a distributive problem and to see that negative as a negative 1. So when I distribute it through, I have a negative 2x, because negative 1 times 2x is the opposite of 2x, which is negative 2x, and negative 1 times negative 7 is positive 7. Now suppose we have some compounding of our variables. 3x times 4, well, 3 times 4 is 12, and I just attach the x. 3x times negative 2x, we just multiply the coefficients. Remember, the coefficients are the numbers attached to the x. We get negative 6. And x times x we write as x squared. I'm going to give you two that I want you to work through on your own. So pause the video, give them a try, And when you think you got the answer, unpause it, and we'll see the walkthrough. So go ahead and pause the video now. Okay, so in the first one, 2x times 3a, we multiply the coefficients, it gives us 6. X and a get multiplied together to give us xa, and it doesn't matter what order we put them in. Out of preference, I tend to put them in alphabetical order just for neatness. 2x times 4b, I multiply the 2 and the 4 and I get 8. And I alphabetize that b and x to get bx. 2x times negative x is going to be a negative number. And when I multiply the x by the x, I get x squared. Oops. So there's our answer. The second one, negative 3 times 2x squared. Negative 3 times 2 is negative 6. And then I just attach my x squared. Negative 3 times negative 4x. Negative 3 times negative 4 is positive 12, and I attach my x. And negative 3 times negative 5 is a positive 15. So that's my answer. If you have any questions, feel free to watch the video again, or feel free to look up any other videos on the distributive property.